Okay, we're going to talk about section 1.6, which is on inverse functions. So before we talk about inverse functions, let's first talk about temperatures. Let's say you're traveling outside of America where basically everyone uses Celsius temperatures. It doesn't make sense to me. I don't entirely get it because Fahrenheit temperature is based on the way that the temperature feels to a human, whereas Celsius is based on how it feels to water. But I digress. Um, so, for instance, to me, I have no idea what 26 degrees Celsius is. Right? I have no idea what this is in Fahrenheit. Um, I can't conceptualize personally of what this might feel like. But there is a formula for converting between Celsius and Fahrenheit temperatures. This formula is Celsius is equal to 5 ninths times Fahrenheit minus 32. So if I wanted to convert 26 degrees Celsius to Fahrenheit, let's see, I could just plug in 26 for C, and this is 5 ninths times F minus 32, and I can solve for F here, right? I can multiply both sides by 9 fifths to get rid of this 5 ninths. This gives me 26 times 9 fifths is equal to F minus 32. And so F is equal to 26 times 9 fifths plus 32. And this is about 79 degrees Fahrenheit. So 26 degrees Celsius is about 79 degrees Fahrenheit. But if I wanted to keep converting Celsius temperatures to Fahrenheit, this formula could get a bit cumbersome to use, right? Having to solve for F every single time. Wouldn't it be better if I just had some kind of formula that takes the Celsius temperature and instead it outputs the Fahrenheit temperature? That's this idea of an inverse function. Instead of, so this function that I gave us here, this formula, takes a Fahrenheit temperature and it outputs a Celsius temperature, right? But I could devise another formula that instead takes a Celsius temperature and outputs a Fahrenheit temperature. This is the idea of an inverse function, where my input becomes my output and my output becomes my input. The definition of inverse function is if f of a is equal to b, then g of x is an inverse of f if g of b is equal to a. The inverse of f of x is typically denoted, or typically notated with this f inverse of x. So equivalently, if f of a is equal to b, then f inverse of b is equal to a. So notice here that this raised -1 used in this notation for my inverse function. This is simply a notation. This doesn't actually designate any kind of exponent here. So let's say that for some function, f of 2 equals 4. What do we know about the inverse of this function? Well, an inverse reverses which quantity is input and which quantity is output. So if f of 2 is equal to 4, then for the same function, f inverse of 2, well, I guess, the inverse function is a different function, but I digress. F inverse of 4 is equal to 2. My inverse function accepts my output and it spits out what the input was. It swaps my input and my output. Similarly, if I have some function h, and I know that h inverse of 6 is 2, this means that h of 2 is equal to 6. All I do here is swap my input and output. So notice that my original function and my inverse function undo each other. This is very important. If f of a is equal to b, once again, we have that f inverse of b is equal to a. This returns us to our original input. Now, if I compose these together in any way, let's say I have f inverse of f of a. Well, if I compose these functions together, I'm going to get my original input as my answer. So f inverse of f of a is equal to a. And this we could justify by saying, let's say if f of a equals b, right? And f inverse of b is equal to a. So let's say that f of a is equal to b. Then I would be taking f inverse of b, and that spits a out. These undo each other. Same thing if I compose this the other way. If I have f of f inverse of b, for instance, then I'm going to get whatever's on the inside of this function here. These are going to undo each other. I'm going to get b. So since the outputs of the function f are the inputs to f inverse, the range of f is the domain of f inverse. Likewise, this means that the domain of f is the range of f inverse. Since all I'm doing is swapping my inputs and outputs. So let's say, for instance, the function f of x equals 2 to the x has domain negative infinity to positive infinity and range 0 to infinity. What would we expect the domain and range of f inverse to be? Well, the domain of my original function is going to become the range of f inverse, and the range of my original function will become the domain of f inverse. I'm just swapping my domain and range here. So this means that f inverse would have domain 0 to infinity, and range negative infinity to infinity. Let's see here. Let me find a good example of how to find an inverse function here. So let's look at the function that we discussed at the beginning, that Celsius, that Fahrenheit to Celsius conversion function. We had the function C equals 5/9 times F minus 32. And we solved this for F, right? So this time, let's solve in general for F. Let's not just solve for some number. So let's multiply both sides by 9/5. This gets me that 9/5 C is equal to F minus 32. And then I add 32 to both sides, and I get F is equal to 9/5 C plus 32. So this is a function for converting Celsius to Fahrenheit in general. And this is an inverse function of the original function that we found here. It is important to note that not all functions will have an inverse. In order for a function to have an inverse, it must be 1-to-1. This means that the horizontal line test actually allows us to determine if a function has an inverse or not. For instance, f of x equals x squared is not 1-to-1. So if I wanted to find an inverse for that function, I would have to restrict its domain. Let's look at some examples on how to find inverse functions. We have some pretty simple ones here. So let's look at if we have, say, f of x equals 11x plus 7. In order to find inverse functions, what I find easiest to do is to follow this process. First, I'm going to rewrite f of x as y equals instead. I'm going to rewrite, I'm going to replace, or rather I guess I will replace f of x with y. Maybe that's a better way of phrasing it. They're really the same thing. This helps me see what's going on better, I suppose. So if I replace f of x with y, then this then becomes y equals 11x plus 7. Step number 2, some people solve for x at this step. I I prefer to swap x and y. And by swap x and y, I would just mean replace them with each other. So replace the y with an x, replace the x with a y. Let me draw some lines here so maybe it's clear that these go with this. For step 3, solve for y. So if I solve for y here, I have to subtract 7 from both sides to get 11y equals x minus 7. I then divide both sides by 11 to get y equals x minus 7 over 11. And step 4 is replace y with f inverse of x. Just rewrite this, but replacing y with f inverse of x. So this says f inverse of x is equal to x minus 7 over 11. Let's look at another one. Let's find f inverse of x for, let's say, f of x equals 2 minus x. So again, I replace f of x with y equals. I swap my x and y, and I solve for y. I'm going to add y to both sides to get y plus x equals 2. I'm going to subtract x from both sides. Yeah, I suppose this works. Wait a second. Yeah, okay. To get y equals 2 minus x. And in this case, again, I just replace f inverse. I just replace y with f inverse of x. This is 2 minus x. So now if I try to compose these, let's see, f inverse of f of x, for instance, this is f inverse of 2 minus x. F inverse of x is 2 minus x, so this is 2 minus 2 minus x. And this is, let's see, 0 plus x, so this is x. This function is its own inverse. Maybe we'll look at another one. Just 1 second. Okay. Let's look at if f of x equals x over 2 plus x and g of x equals 2x over 1 minus x. Let's find f of g of x and g of f of x let's find f of g of x and g of f of x. So f of g of x is f of 2x over 1 minus x. And this is, let's see, I'm going to place parentheses here, 2x over 1 minus x divided by 2 plus 2x over 1 minus x. I need a common denominator down here, so I need to multiply this 2 by 1 over x minus 1 over x. So that this is 2x over 1 minus x all over 2 times 1 minus x is 2 minus 2x. And then I have plus 2x. This is all over 1 minus x. Now that I've obtained a common denominator down here. And this is 2x over 1 minus x divided by let's see. This looks like just 2 over 1 minus x. Now when I divide by a fraction, I multiply by the reciprocal of that fraction. So this is the same thing as 2x over 1 minus x times 1 minus x over 2. Notice here that my 1 minus x's cancel. 2 divided by 2 is 1. I'm going to get just x here. Okay, so f of g of x here is x. Let's find what g of f of x is. G of f of x, this is g of x over 2 plus x. And this is 2 times x over 2 plus x divided by 1 minus x over 2 plus x. Once again, in the denominator, I need a common denominator between the two fractions here. I have to multiply this 1 by 2 plus x over 2 plus x. This gets me, let's see, 2x over 2 plus x divided by, let's see, 2 plus 2x minus x over 2 plus x. This is 2x over 2 plus x divided by, what do I have here? 2 plus x over 2 plus x. Is this correct so far? Let me just make sure I didn't make any mistakes. This would be 1. Let's see, where did I happen to make a mistake at here? I'm certain I made a mistake in the copying. I'm trying to find where in the copying I made a mistake is all. X over 2 plus x. Okay. I made a mistake whenever I did this multiplication. That's what I did. So that's my bad. Up here, 2 plus x times 1, that's 2 plus x, right? Okay. There we go. See, even I can make a careless error here if I'm trying to rush through this too quickly. Now 2 plus x minus x, this is 2, over 2 plus x. Once again, whenever I divide by a fraction, I multiply by the reciprocal of that fraction. So this is 2x over 2 plus x. Oh, sorry, my drawing tablet got a little bit turned there. This is 2x over 2 plus x times 2 plus x over 2. So I have 2 plus x over 2 plus x. Those are going to cancel. And I have 2 divided by 2 is going to be 1. So this is x. So here, I got that f of g of x is equal to g of f of x, which is x. This means that f of x and g of x are inverses of one another. Okay, and that'll be it for 1.6.